Question 19 says number of molecules in a volume of 4 cubic centimeter of a perfect monoatomic gas at some temperature T and at pressure of 2 centimeter of mercury is close to, and there is a question mark, and the information given is mean kinetic energy of a molecule at temperature T is 4 into 10 to the power minus 14 erg. Value of G is given as 980 centimeter per second square, and density of mercury has been given is 13.6 gram per cubic centimeter. Clearly the question is related to the kinetic theory of gases. It is also about finding the pressure in terms of the length of the mercury column. We need to convert that. Now since the units here are CGS, we shall convert that pressure into CGS units by putting pressure as rho GH. And since we have to find the number of molecules, so let us start with the ideal gas equation, the equation of state. PV is equal to nRT, but in the equation PV is equal to nRT, N is the number of moles, and let us convert this into the number of molecules. If we do that, this becomes capital N into K into T, where capital N is the number of molecules and K is the Stephen-Boltzmann constant. So this is the equation. We are interested in finding N. The expression for N from this equation is that number of molecules is equal to PV divided by K into T. T is the temperature, P is the pressure, and V is the volume. What else is provided to us? For P we have rho GH. So we can write P is equal to rho GH, and we can stick to the CGS units. All the quantities are given in CGS units. What about KT? Now there is a very important information given that the mean kinetic energy of a molecule at temperature T is given as 4 into 10 to the power minus 14 erg. Now since it is a monatomic ideal gas, the average kinetic energy per molecule will be given as 3 by 2 kT. So that means the value of 3 by 2 kT is given to us as 4 into 10 to the power minus 14 erg. Let us write here, we have 3 by 2 kT. So that is given as 4 into 10 to the power minus 14 erg. So again that is the CGS unit, the erg is the CGS unit of energy. So we have the value of KT, okay. So do we have everything? Yes, we have. Rho is 13.6 gram per cubic centimeter, G is 980 centimeter per second square, and the value of H is 2 centimeter, is it not? So let us put in all these values, and value of KT we can substitute here. It will become 8 into 10 to the power minus 14 divided by 3 CGS units. So this becomes then, for rho we put 13.6 gram per cubic centimeter, the value of G is 980 CGS units, value of H is 2 centimeter. So let us put it here as 2 centimeter, and for KT we have 8 into 10 to the power minus 14 divided by 3. So this is 8 into 10 to the power minus 14 divided by 3. So this is the number of molecules. We can simplify this, and on simplification it comes very close to the value 4.0 into 10 to the power 18. So that means for this question option 4 is the correct option. Let us go to question number 20 now. Question 20 says a square loop of side 2A and carrying current I is kept in XZ plane with its axis at origin. A long wire carrying the same current I is placed parallel to the Z axis and passing through the point 0, B, 0, where B is very large compared to A. the magnitude of the torque on the loop about z axis is given by, well, the question is from the topic moving charges and magnetism, it is about torque on a current loop due to a magnetic field. Now, the information that is given to us, B is very large compared to A, enables us to consider that the magnetic field is uniform. Okay? That will be very critical in solving this particular question. Let us depict the situation with the help of a diagram. Let us say that the loop is placed in the xz plane. Let us call this as the x axis. This is the x axis. Let this be the y axis. Okay? And this of course is the z axis which is coming outward. Let us show it here. So, the square loop is placed something like this, it is in this particular plane, in the xz plane, and let us say it is something like this. This is how the square loop is placed in the xz plane. We have to visualize that it is in the xz plane, right. The side length is given as 2a and the current is parallel to the z axis, because the wire is parallel to the z axis and it is passing through 0 comma b comma 0. That means we can take that the current is coming through this point, it is parallel to the z axis. This current is also I, and of course the current in the loop is also given as I. The side is 2a, the current let us assume is I. In fact, it is given in the question. Now, it is a pretty straightforward question. If we look at the m vector, the magnetic moment vector of this dipole, that is equal to 4a square I, and the direction is along j cap for the situation that we have shown. So, the m vector, let us write here itself, is coming out as 4a square into I. The direction is the j cap direction. What about the magnetic field? Well, the magnetic field at the origin is given as mu naught I by 2 pi b, that is the magnitude, because this distance is b. So, what about the direction of that magnetic field due to the current I, which is flowing along the z axis? That direction will be along the x axis at the origin. Now, since b is very large compared to a, we can consider the magnetic field to be uniform. So, the expression for the magnetic field can be taken as b is equal to mu naught I divided by 2 pi b, and the direction is in this particular case along the I cap direction. Now, it is a pretty simple thing. We have to find the torque. Torque is m cross b, and we are concerned with the magnitude only because the options are given in terms of magnitude. So, m cross b magnitude then becomes 2 mu naught a square I square divided by pi b, which is matching with option 1. So, for this question option 1 is the correct option. Let us slide it and go to question number 21 now. Question 21 says a force F I cap plus 2j cap plus 3k cap Newton acts at a point 4 I cap plus 3j cap minus k cap meter. Then the magnitude of torque about the point I cap plus 2j cap plus k cap meter will be root x Newton meter. What is the value of x? It is the integer type question. Let us find the value of x. Now, the question is relating to torque about a point. So, what we are interested in, of course, let us call these points, let us give these points some name. Say this is point P, let us call this point P where the force F is acting, and we have to find the torque about this point. Let us call this point as A. So, the expression for torque about a point is, torque is equal to R cross F. What is the R vector? Here we are interested in position vector, that means R of P with respect to A, and this is given as position vector of P minus position vector of A. In this case, that simplifies to 3 I cap, because 4 minus 1 is 3, then 3 j cap minus 2 j cap, that means plus j cap, and minus k cap minus 2 k cap meter. That is the position vector of P with respect to A. F vector of course is given to us. So, the torque of the force about point A is given as, let us use the determinant form. So, this is I cap, j cap, k cap, and then we have x, y and z components of RPA, that means 3, 1, minus 2, and then x, y and z components of force, which is 1, 2 and 3, and this of course will be in terms of Newton meter. So, we need to simplify this, and this on computing comes out as 7 I cap minus 11 j cap plus 5 k cap. Of course, the unit is Newton meter. Now, we are concerned with the magnitude of this torque. If I just calculate the magnitude of this torque, this is coming out as under root of 7 square plus 11 square plus 5 square Newton meter, and this is in fact root 195 Newton meter. So, now we have to compare root 195 with root x. So, the value of x is 195. So, that means the answer to this numerical type question is 195. We go now to question number 22.